For millions of people, managing high cholesterol is a repetitive routine that effectively becomes a permanent fixture of daily life. This is the current medical reality of chronic maintenance. Our healthcare model focuses on endlessly managing a risk factor rather than fixing the biological cause. The target of this daily effort is LDL, the bad cholesterol. Keeping these levels low is the primary way we prevent long-term cardiovascular damage. But because the medication is temporary, the regimen requires strict, unbroken adherence for years or even decades to remain effective. It is a heavy toll. Millions of patients are tethered to a daily pill bottle simply to stave off the threat of heart disease. That cycle of daily maintenance highlights a different possibility, a single, permanent intervention. An experimental treatment called VERVE-102 is testing this through an intravenous gene editing therapy. This moves the medical focus away from temporary chemical suppression and toward direct genetic modification. Instead of tracking decades of repeated prescriptions, the timeline for this treatment is a single afternoon infusion. If later trials prove successful, this approach would trade the logic of lifelong medication for the possibility of a one-time treatment. To understand how this works, you have to look at the liver. It acts as the body's primary filter, responsible for pulling LDL cholesterol out of the bloodstream. But a specific gene called PCSK9 creates a bottleneck. It produces a protein that limits the liver's ability to clear that bad cholesterol effectively. VERVE-102 uses base editing to target this gene directly within liver cells. This edit effectively switches off the PCSK9 gene, stopping the production of that restrictive protein. By removing this genetic bottleneck, the liver is free to clear bad cholesterol on its own, without the need for a daily external drug. In May 2026, the first results of an early-stage study were published in the New England Journal of Medicine. The trial involved 35 adults with either premature coronary artery disease or an inherited condition that causes dangerously high cholesterol. Each participant received a single intravenous infusion, which the researchers tested at several different dose levels. At the highest dose, LDL cholesterol levels fell by an average of 62%. One investigator described the data as an extremely exciting milestone, even though the study's primary goal was to evaluate safety. These results offer a clinical proof of concept that a single genetic edit can achieve the kind of reduction usually only seen with years of daily medication. However, this is still early-stage science. The study was small, and a primary focus on safety does not guarantee a long-term cure. The first major unknown is durability. Researchers need to follow these patients for years to see if the cholesterol-lowering effect actually lasts. Then there is the question of safety. We don't yet know the long-term impact of making permanent genetic changes to human liver cells. Finally, larger trials must prove that lowering LDL in this specific way actually prevents heart attacks and strokes in the general population. While the potential is significant, the permanence of altering DNA requires years of rigorous observation before it can be considered for widespread use. Despite these hurdles, VERVE-102 marks a change in direction for cardiovascular medicine. If subsequent larger trials confirm that the treatment is safe and effective over the long term, the way we treat heart disease will shift. Some patients may soon be able to neutralize a major heart risk in a single day, ending a lifelong reliance on daily pills. The ultimate promise here isn't just managing a condition, but removing a major disease risk factor from human biology entirely.